Think of yourself on a carousel spinning at full speed, but instead of spinning upright, you are tilted almost on your side at 60 degrees. In space, there is no real concept of up or down, and yet our entire solar system is traveling sideways through the galaxy, tilted, off balance, at an angle no school diagram ever shows you. If we are tilted, the question becomes simple. Tilted against what? Something has to be the reference. Some flat surface somewhere out there that defines what straight even means. That reference exists, and once you see it, the geometry of where we are makes a different kind of sense. To say something is tilted, you need a reference. On Earth, gravity gives us one for free. The ground is down, the sky is up, and we never have to think about it. In space, that simplicity disappears. There is no gravitational floor, no universal horizon. The universe does not come pre-equipped with a baseline. So, when astronomers talk about the plane of the solar system, they are picking a reference. The most natural one is the ecliptic, the plane traced by Earth's orbit around the Sun. The other planets are mostly aligned with it, within a few degrees because they all formed from the same flattened cloud of gas and dust 4.6 billion years ago. There is also a more precise version called the invariable plane. It accounts for all the angular momentum in the solar system, including the gas giants. The invariable plane is tilted by only 1.58 degrees from the ecliptic. So small that for most purposes you can treat them as the same. Either way, this gives us a natural floor, the plane where the planets live. And then there is the Sun. The Sun itself is tilted against this plane by about 7 degrees. The Sun, the center of the system, the gravitational anchor that holds everything together, is itself off by 7 degrees from the plane of the planets it created. It does not share their orientation. Why? Nobody knows for certain. One leading hypothesis points to a possible undiscovered ninth planet far in the outer solar system, whose gravity may have slowly tilted everything over billions of years. Another hypothesis points to a close encounter with another star early in the Sun's history. A third, more speculative idea points to primordial magnetic fields in the original cloud of gas that gave the system an initial twist. The mystery is genuinely open when it tells us that even inside our solar system, the idea of being straight is relative. The center is tilted against its planets. The planets are tilted against each other. There is no single canonical plane, only what we choose to measure against. So far, we have been looking inside the solar system. The real surprise comes when you zoom out. The solar system is not floating alone in empty space. It is one small spinning system inside something vastly larger. The Milky Way galaxy, a spiral disk of 200 billion stars stretching across 100,000 light years, organized into a flat plane of gas, dust, and starlight. We sit roughly 2/3 of the way out from the center, in a quiet spiral arm called the Orion Arm. Every clear night, when you see the Milky Way arching across the sky as a faint band of light, you are looking at the rest of the galaxy edge-on from inside. The galaxy has its own plane, the galactic plane, the flat layer where most of the Milky Way's mass and stars are concentrated. It is the closest thing to an ocean surface that our region of space has. Our solar system is tilted against this galactic plane by approximately 60 degrees. 2/3 of the way to perpendicular. Think of the galaxy as an enormous flat ocean. We are not a boat floating upright on its surface. We are a boat sailing almost on its side, hull pointed sideways, deck tilted toward the stars above. The galactic plane is the reference, the floor of our local universe. It is what we are tilted against, and most textbooks never mention it because the view they show is always local. The consequence of this tilt is something you can actually verify for yourself every night. Look up at a clear sky away from city lights. The Milky Way crosses the heavens at a sharp angle, not parallel to the horizon, not perpendicular to it, but somewhere in between. That angle you see is the geometry of our tilt. It is the direct visual consequence of our solar system being oriented sideways relative to the galaxy that contains us. The tilt also determines what regions of interstellar space we pass through over time. denser layers of dust and gas, thinner layers, the composition of the local sky changes based on where our tilted orbit takes us through the structure of the disk. The tilt changes how we move through the galaxy too. The Sun orbits the center of the Milky Way at roughly 800,000 kilometers per hour, or 490,000 miles per hour. The full orbit, called a galactic year, takes about 230 million years to complete. The last time the solar system was in this exact position in the galaxy, the earliest dinosaurs were just appearing on Earth. And while the Sun moves forward through the galaxy at that speed, the planets are still doing their own thing, orbiting the Sun year after year at their own speeds and at their own angles. The combined motion traces something most people have never seen drawn correctly. Think of a spiral staircase. The Sun is the central pole, moving straight forward through the galaxy. The planets are wrapping around it as they orbit, drawing helical curves through space like a corkscrew. Earth's path, traced over millions of years, is not a circle. It is a long, gentle spiral, threading forward through the galaxy at 800,000 kilometers per hour, while also winding around the moving Sun at its own orbital pace. Static orbits are a convenient simplification for textbooks. The real motion is dynamic, threaded, always moving forward, never returning to exactly the same point twice. There is one important detail worth getting right, because a lot of popular animations get it wrong. Some viral videos show the Sun leading the planets like the head of a comet, with the planets trailing behind in a wake. That is not how it works, because our orbital plane is tilted at 60 degrees against our direction of motion. The planets are sometimes ahead of the Sun and sometimes behind it, depending on where they are in their orbits. The motion is helical, but it is not awake. What is real and worth pausing on is that we are not just orbiting. We are falling forward through the galaxy at speeds that defy ordinary intuition. The fastest manned aircraft ever built, the SR-71 Blackbird, topped out at 2,200 miles per hour. The Sun's orbital velocity is more than 200 times faster than that. While you finish watching this video, the solar system will have moved roughly 80,000 miles through the galaxy, more than 3 trips around the Earth. And we are not moving in a straight line. We are riding a vast circle around the galactic core, tilted, helical, threading through the disk of the Milky Way at a 60-degree angle. Every star you see in the sky is on its own version of the same kind of journey, each one tilted at its own random angle, each one threading its own helix. There is a specific direction we are headed, by the way. If you go outside tonight and find the constellation Hercules, you're looking at the front window of the spacecraft we are riding. The solar apex, the direction the Sun is moving through the local neighborhood of stars, points toward a star called Lambda Herculis, about 370 light-years away. That is the bow of our ship. The Sun has been pointed roughly that way for longer than mammals have existed on Earth. The natural intuition is that the solar system should be aligned with the galaxy. Same galaxy, same disk, same rotation, wheel inside a wheel. But stars do not form that way. Stars do not form from the rotation of the galaxy as a whole. They form inside small, dense clumps of gas inside vast clouds called giant molecular clouds. Each clump is its own little pocket of swirling material with its own local rotation, set by the random turbulence of the gas around it. When a clump collapses to form a star, the disk that forms around it inherits the rotation of that local clump, not the rotation of the galaxy. So the orientation of the new solar system is essentially a roll of the dice. A 2025 microlensing study by Valerio Bozza and Paulo Rota analyzed 66 distant planetary systems detected through gravitational lensing. They specifically tested whether those systems showed any preferred alignment with the Milky Way's disk. The answer, with one minor exception in the Scutum Centaurus spiral arm, was no. The orientations were essentially isotropic, random in every direction. Which gives us the first piece of the answer. The gas cloud that formed our Sun happened to be spinning in a direction that did not match the galactic rotation. That set our orientation at the moment of birth 4.6 billion years ago, and it has barely changed since. But there is also a second possibility. Even if our system started somewhere aligned, the passage of other stars over billions of years could have nudged us. The Milky Way is full of moving stars. Statistically, close stellar encounters with the early solar system are likely to have occurred multiple times in the deep past. Each encounter would have tugged on the outer solar system, slowly torquing the whole structure into a new orientation. And there is a third, more recent idea. The same hypothetical Planet 9 that might explain the Sun's 7-degree tilt could have nudged the entire planetary plane over the last few billion years. If a massive unseen planet exists in the far outer solar system on a steeply inclined orbit, its gravitational influence could be slowly pulling the rest of the planets into a tilted configuration. Most likely, all three effects contribute: random initial conditions from the birth cloud, gravitational nudges from passing stars, and internal perturbations from whatever else hides in our outer solar system. The 60-degree tilt is not a single mystery with a single answer. It is a cumulative result of 4.6 billion years of cosmic history, placed out on a system that started off balance and has been adjusted by every passing influence since. All of this changes how you can see the night sky. Next time you step outside and look up at the stars, don't see them as being above you. They are not. See yourself instead at the window of a tilted ship racing through space at 490,000 miles per hour, hull pointed sideways, deck tilted at 60 degrees against the galactic ocean. The stars you see are not floating quietly. They are sailing past you, each one on its own tilted journey, each one threading its own helical path through the Milky Way. The galaxy is not really a clockwork mechanism with everything aligned, but something closer to a swarm. Billions of stars orbiting the same galactic center, all pointed in different directions. And on one of those tilted systems, on the third planet from a small yellow star, on a thin layer of rock and water and air, someone is watching this video, now wondering for the first time which way they are really pointed, including you. And you, would you feel safer if our solar system were perfectly straight, aligned cleanly with the galaxy? Or would you take the 60-degree journey we are actually on? Let us know in the comments. If you want to see what surrounds us in this tilted journey, above and below the plane of our planets, in directions the textbooks never show, watch what exists above and below our solar system next. It is the natural follow-up to this video.